Hello, good day. Today's webinar is on field data collection process validation with predictive analytics. My name is Ted Stewart, and I am the program development and compliance manager here for Exida. I wear a lot of different hats. If some of you do not know, I'm an OEM account holder. I do a lot of project management. I also am the deputy quality manager. I help with the end user logistics. I help out with the CFC program. And my background is that I previously worked as a manufacturer for new products and development with Harris Corporation, and then I was also a test engineer for Lockheed Martin. As always, we do have new people constantly joining us for these webinars, so I'd like to share a little bit about our company information before we get started. As you see here, there's a bunch of little red dots everywhere on this map. Yet we are a global company. There's usually a small red dot next to or close to somewhere where you live, and every year it seems like we're growing one or two more red dots, I should say. Exida is involved with the complete supply chain of functional safety in multiple industry sectors, from the original equipment manufacturers who require this product certification all the way to the other side, which is the manufacturer's customers, the end users, that actually use the products. Exida provides software tools, training, consulting, and procedures related to functional safety, to security, and also reliability. We have many engineering tools. You'll see here in front of you, we have alarm management, we have FACS, we have the SIL selection tool, SRS tool, SIL verification tool, proof test specification, and I think for today's webinar, the most important one is going to be SILstat. And this is a data collection tool, and you're going to learn as to why it's so important to validate and collect true field failure data. So what is SILstat? Well, SILstat, it does capture key operational and maintenance data. It's basically a review and analysis that are required for IC 61511, ISA 84.00.01, and it's also part of the compliance with OSHA. As you see here, there's some built-in features where there's an event recorder. It does your built-in failure taxonomies, data analysis service, and then also your predictive, which includes your predictive analytics, which is one of the main topics we're going to be speaking about today. I love this slide, mainly because it makes our job, I wouldn't say easier, but it helps us explain what we do. Because we're accredited by ANSI, anything that's not public knowledge we can't really share because it's looked at as consulting. And because we have to be impartial to all the different companies that we work with, anything that's not public information we have to keep to ourselves. So what does Exida do? We publish everything. We'd rather be an open book than a closed book. We'd rather share everything we know so that it's out there on the table. And the difference is we just do it every day. And so that's why we're so efficient at what we do, and that's why we learn what we learn. And most of the money that we make here within Exida gets reinvested into research. And that's why you see all the books here in front of you today. We have a lot of different products, a lot of different services. We kind of summarize them here in this slide today. We do have a consulting branch that's not in product certification. Therefore, we're allowed to do it. That's usually for our end users. It's for alarm management. It's for cybersecurity. I touched already on the engineering tools. We have product certification in 61508, and we also have some certification work in 26262. We have training. Basically, we have one training somewhere in the world at least once a week, as you know, about the reference material. And then, of course, we have our professional certification for personnel competency, which is the CFSE program, which also contains many different specialties such as automotive, cybersecurity, hardware, software, process, and machinery. Now, okay, we're going to start talking about the fundamental concepts and start getting into more detail about today's webinar, because there's many benefits to a company when they have access to good field failure data. And most of these benefits are actually categorized as saving money. And at the same time, most of the expenditures to get good failure data is already being spent by these companies and given an incremental cost of improving maybe your data collection quality and getting that better analysis, you can actually achieve a nice return on investment. And many people don't realize that, and it starts at the concepts. So it kind of answers the question, because we get this, well, why do I care about these failure rates, and and so why are you listening today for this webinar? Well, the fundamental concept is the probabilistic performance-based system design, and that's what we're going to be talking about. And then, of course, the other side of it is your detailed engineering process, okay? But we're really going to focus on this probabilistic performance-based system design. In the life cycle, number 11 is where the probabilistic performance analysis takes place. All right, and in the past, I'm sure many of you have already listened to other webinars, and there's one webinar that goes more into detail on step 11, which is the 3 barriers to SIL certification. However, the key point for now is the manufacturer safety manual and the failure rate database. And this is what we're going to be speaking about. Getting failure data, you can do so in many, many different ways. In the 1980s, 1990s, really the only way that you could get any kind of information was typically through military, telecom based on their failure data collection, and there wasn't many databases out there. Now you can get all kinds of different data. You can get you can see there's new standards that create a framework, which I'll talk about later. You have your manufacturer field return data studies, your B10 data and user information, and then of course you have the FMEDA. And as I get more into detail, because I think a few that are already popping up, if you have a question, you got a bar right there. Go ahead, type your questions. I'll get to them most likely at the end, unless I can squeeze it in to where I'm talking about if I see it in time. Let's talk about each one of these different ways of getting failure information, because there's good ways, there's okay ways, and there's bad ways. And we can kind of go through and explain the differences between the different types of data. And I talked about the industry database, right? And we're going to look at some different standards and some of the databases that are out there. The next one is your manufacturing field data. So, I mean, the first thing you have to realize is, okay, what percentage of actual failures are returned? And I think perhaps the biggest level of optimism comes from the assumption that all field returns or all field failures are reported. Now, we did do a survey from end users, and what we found is that it's often cheaper to throw away a product than it is to actually send it back to the manufacturer. And sometimes repairs are made by the end user, and the failure is not even reported to the manufacturer. Now, this is especially true of mechanical devices like valves, actuators, where you rebuild where these rebuild kits are actually sold. Overall, the end user survey results that indicate that only probably 10% of failed items were returned back to the manufacturer. Now, of course, this number does increase if it's within that warranty period, but outside that warranty period, some reports that we received back said that they believe 0% are returned back to the manufacturers. And I mean, I think if you are a manufacturer, you can understand that, and if you're an end user, you would probably agree with that. And that's just what our survey and our information are telling us. All right, so manufacturer data, though, is very important because it's a real failure. It's a real information. You can look into it, and you can typically figure out if you're a manufacturer and you're doing your own study, you can figure out if there's any outliers, if there's consistent problems with a product, and you can fix those and improve upon it. That's our biggest thing. We want to improve, and we want to learn from our products. The next thing is B10 data. If you're not familiar with B10 data, it's basically used in machine safety. And what is machine safety? Machine safety is where they move really fast, and the reason for failure is always primarily it's the wear out. All right, they don't really fail in between. It usually fails because it moves all the time and it just wears out. And because we're in the process industry within functional safety, we don't really worry about fail out, because why? Our products aren't used that much. They don't do, because if it uses that much, then there's something wrong with your system, because you don't want something to fail into a safe manner, failing a dangerous manner, because usually the products are dealt with when a bad situation occurs, right? And then that's when the safety function plays a part. So manufacturers and B10 data, they aren't really the best sources of information. We feel that has the most potential is the end user field failure data. Why? It's because that product is out in the real world, quote unquote, and you get the real data. However, many systems, the existing systems to collect this data is pretty weak from what we've seen. And you have to understand that when we're seeing this information, it's not just collecting it, you also have to realize, well, what are these assumptions that are being made, especially with manufacturers? You have to first understand, what is the scope? Is this a pressure transmitter with an impulse line, or is it without an impulse line? What kind of technology does this product use? Does it say that in the failure return information? What is the product number? Does it talk about, okay, do they define a failure? Is it a random failure? Is it a systematic failure? Was it a wear-out failure? All of these things, in order to have great field return information, need to be documented. We can't just simply record the information. We need to know more about it. You need the product identification. You need to know what kind of proof testing was involved. Does it have automatic diagnostics, and so forth. So there's a lot of different categories. We could definitely help some people out if they need to know, okay, well, how do I improve? Where can I start? And things of that nature. However, these are just things to bring awareness. And of course, you do have FAMIDAs, which is that predictive technique developed by the engineers here at Exida, which what we do is we use a component database that accounts for the design and the strength. And like I said earlier, manufacturer field return information is good. However, we can't use it in any of our FMEDA work, and B10 data for our industry just does not apply. So some of the industry databases that we're very fond of is ERIDA. It's updated every few years. We've even visited this facility in Norway. We reviewed the data collection and analysis techniques with some of the engineers from Syntef. As you can see there, they're located in Norway. They provide useful data on process equipment in generic categories. The interesting thing with ERIDA is you can't really compare it to apples and apples. It's more so, it's basically a product grouping where, for an easy example, it's kind of like you have apples, you have oranges, you have bananas, and so really you just have fruit, right? And so it gives you failure data of a reduced accuracy for all elements in that group. Why? Because they kind of throw everything together. You don't really know if it's, let's just say, is it a ball valve? Is it, do they, there's a gate valve, there's ball valves, there's all these different types of valves. However, they just kind of put it all into one and say, this is a valve, and here are your failure rates, which is fine. However, we take it to a different step and we separate everything. So if you have a specific product, we do failure rates on that specific product, and then that's how we differentiate ourselves from them. So they're just more generic, right? And you can see here in that problems, it's hard to use in designs as data is significantly aggregated, and which that means you can't get the detailed failure data for a specific data for a certain type, okay? And another situation that we found is if it's a new product, you will not have any kind of information available for many years until that product has become used, trusted, and it has the amount of hours required to put into the system, into the database. So let's talk about end user failure studies. Field failure studies with significant information represent a rich opportunity, right, to obtain site-specific failure rate and failure mode information about a product in a specific application. End user field failure data has the highest potential. However, insignificant information in the failure reports differentiate themselves, right? Because you have different definitions for what a failure is. You have different methods for this data analysis. There's no consistency. And if it's not defined, that information almost becomes useless. of the standards that are out there that kind of help build a framework of data collection, you have ISO 14224, you have IEC 6300-3-2, you also have NMORD NE93. Now, while these are standards to help, they're not significantly detailed, and even more importantly, many people don't even follow these standards or even know what they are. But the good news is we do more webinars, we can help bring awareness to this, and we can help solve this problem. One of the kind of fun ways to say things is, well, let's say this. You know, we had a colleague that was very proud of information. They said, look, I can hire a statistics expert to completely analyze this data. But then you have to ask, so how do you know if your numbers are right? A statistical expert cannot identify bad data, right? They just look at the data you present to them, and then they can give you a report based off that information. And it's kind of like if you don't have the right information in, you don't get the right information out. And our analogy is more like you get trash in, you get trash out. You're not going to make anything from that. So the key point is if you're collecting bad failure data, you may think that you're doing very well under these false impressions. You got to make sure to validate your data to know if you're truly doing well. So how do you do this? Good field failure data collection program, it has a number of important attributes. It specifies a site inventory database, and it can include basically, you can have your product manufacturer, you can have your model number, the serial number, the design version level, the product classification, an installation site, failure event records and proof test records that include dates, methods, results. You can have all kinds of the calibration information. So when you get a failure, you list all this information. It might take a little bit more work, but it's not an excessive amount of work. And once you gather this information, now all of a sudden things start making sense. Now all of a sudden you start building a database, and you can start seeing where problems lie. All right, and so what kind of system exists, and what kind of system should we have? Well, exida has done that. We've collected over 250 billion unit operating hours of process equipment field failure data from nearly 100 locations. We've also started receiving information from StillStat users that allow us, and this information that you see in front of you is from manufacturers and from end users. And many different systems have been used, and there have been many lessons learned throughout this entire process. Now, we've taken all this information, and we integrated the information and placed it in what is called a predictive analytics. We have the expert reliability engineers can now recognize quality data and now can realize far more accurate results, and actually use this to set it combined into a method, like I've said before, and it's called a predictive analytics. All right. Now, your question is, well, what is this predictive analytics? And what it is basically your FMEDA. All right, because we all know a failure rate is your stress versus your strength, and you want to evaluate the design strengths through the FMEDA technique. Okay, and by looking at a large collection of products, we can now see how the design strengths vary. Right, you're going to have different bounds, and we have created different operating profiles. That's why when you see a report from us, you can see where you're classified and what profile you're classified in. And what we've now developed to help people, because some people, they don't realize where they stand, and they might say, an end user could say, okay, great, well, I see this piece of paper, it has this SIL stuff on it, and they give me these numbers in the back. Is this a good range? Is this right? Is this wrong? Or they might be doing their own analysis, and they come up with their own numbers. And what we've done is there's now a website out there called silsafedata.com, and you can now see a range of products that have these bounds, a higher upper and lower bound. And you can see, okay, this number makes sense. It falls within the range, right? And so you'll see here an example is we did a study of design strengths on 35 different pressure transmitters combined with this field failure data, which shows an upper and lower bound on the total failure rate. Well, if you see there's blue dots, so those are all the different FMEDAs that we've done. You see the green dots, which is ARITA field data and Dow field data. And you can see that there are some numbers outside the limit, or there's one anyways. And so what is that? Well, that basically was a poor design product. right? Because all these pressure transmitters aren't built the same. You have different quality pressure transmitters, and they all take into account, and you get different failure rates because you might have a safer product or vice versa, or a product that's not as safe. And I just want to take a real quick peek at all these questions. Great. Awesome. Keep them coming. And so we can predict by how well a data collection process is working and whether they're collecting information correctly, because then you can start seeing where their boundaries are, where their ranges are, and you can learn from this information. All right, now let's get into it. So here is what we do. We take a set of field failure data, and then we perform a statistical analysis. This statistical analysis is where you can get the failure information, or this failure rate. We then will compare the actual data that was received from the predicted data and ask ourselves, are we out of range? Okay, if we're out of range, well, how far out of range are we? And what's the probability that the data collection process is inconsistent with what we normally see? Right? And so these are the things that you can now take from this information. And I kind of just want to stress the importance, all of this cannot be achieved if at the very beginning we don't accumulate the right type of information, right? So if you're not collecting good failure return information and you're not categorizing it, none of this stuff matters. And if people would take just a little bit more time, and some do, and some are fantastic at it. However, if you're not doing it, look at it, reconsider it, because this isn't anything that you have to hire anyone to do. This is something you are already spending your own time and effort on. You're already doing it at your own facility. If you improve on it by yourself, you can now learn where issues lie on your own. You don't have to. You can hire somebody, but you don't have to. And that's what's so neat, is this is something that you can do yourself. All right, so here's what we found. I have a few different examples. I could go all day on examples. I got 3 of them. I like these 3. So the first one is, an extensive set of test results from a test shop indicated that a manufacturer had an exceptionally low failure rate when compared to the predictive analytics bounds. Okay, here's what we found. An on-site visit to that test shop showed that when each instrument was returned for testing, it was cleaned up. They didn't think they were doing anything wrong. After they cleaned it up, they then tested it. Cleaning for them included they disassembled the product, they replaced any seals, any O-rings that looked kind of damaged, and then they tested it. We were surprised that they were still seeing failures even after doing all of that work and after all that refurbishment. So what do we learn? If you want true failure rates, that test information, that repair information, the data collection process must be understood to correctly analyze field data. Okay, they just didn't specify what their definition of a failure was, and this is why you need to be very clear. You need to do as found conditions; those have to be recorded. Here's another example. We had this one actually. We learned about. We didn't even have to go in and actually perform this one. Data from an on-site repair shop is entered, into a maintenance management system. A lot of people call them an MMS, where equipment failure rates are automatically analyzed. This MMS report showed that the failure rates were much lower than those provided by a cell verification tool which was our tool, the Excellentia tool. Therefore, the proof test intervals could not be extended. The proof test intervals could be extended. However, before proceeding, thank you, engineer, they went and visited this shop, and it was discovered that the failure returns were entered into the MMS system only when a device was sent out for repair. This is not uncommon. And that was how this repair purchase order was generated. So all units repaired internally, they weren't even recorded, and no purchase order was even needed. That data in the MMS system was very optimistic, and long story short, the proof test interval, it actually was not extended. So that was a great find from this engineer, and I appreciate them for sharing that information with us. And as you can see, the test, the repair, and data collection process must be understood to analyze data. As found conditions for all failures and tests must be recorded. And I think that's a very critical part of it. And here's a third example. A field failure study of a valve showed that a low failure rate when compared with the exida predictive analytics benchmark, and conclusion was that this valve, hey, it would be an excellent choice for safety applications. Well, the valve was designed and manufactured for control applications. Although not stated in the analysis report, it may be possible that the data was gathered for a dynamic operating condition of a control valve. The failure rates for the same product in a static application would be much larger, and many other failure modes exist in that static applications, right? All right, well, I do have a question that's on this topic. Thank you. And it was like, the question is, did this example use a control valve in an SIS application with a separate solenoid? Well, we do not know. Since the application conditions were not recorded in the failure reports, we had insignificant information, but someone used that info to calculate a failure without even knowing the application. So we're looking for reasons why the failure rate is so low and outside the limits, right? One explanation is that, well, this valve was used in a control applications where they were moving. And that's so much different where the application is static. So good question. The next thing is you have several data sets that indicate a 2x difference in failure rates from site to site for the same product model and for the same product and model number. And I know in previous weeks I've talked about something called the Site Safety Index. I throw a link on it at the end of the webinar. This is not uncommon as well. You visit one site for the same product and another site with the same product, and you compare failure rates, and they're going to be different. In some places, they're a couple X different. And why is that? It's because they haven't defined their process correctly. One's doing one thing, one's doing the other thing. And when you don't have an identified process in place and they're not doing the exact same thing, you're going to achieve different results, right? And so what's going to have to happen is you're going to want to do a root cause analysis that's going to show the differences in this product selection process, maybe in your maintenance, your testing, in your repair procedures. Now you want to use this field failure data that will actually help identify these areas. Your product-specific failures, whether it's internal failures of the device, and then also your site-specific failures. And these things will start getting categorized and put into areas so that now you can actually do some research and look at everything. And you can reduce the failure rate by doing these root cause analysis since you have that validated collection process. Without this validated collection process, you're not able to do any of this information or any of this analysis. And one thing I do want to touch on, because I know I get questions on this all the time, is anytime you guys want to look at failures, right? Failures are looked at as a bad thing. And in reality, yeah, they're bad because you don't want anything to fail. However, it's going to happen. But you need to encourage people to record these failures. And any suspected cause, it should never be recorded. Like if there's a maintenance mistake, you should never. These mistakes should never be used to reprimand somebody or to even evaluate the team, right? So if you have a team and these failures, you should never use this against them. Why? Because all of a sudden now you're not going to get these failures anymore. They're not going to want to record them because they're just going to get in trouble. And so you don't want to make this a negative thing. This needs to be a very positive thing. People need to learn and understand that failures are not bad if you collect them early. If they go out to a customer and user, now all of a sudden they become very bad. But if you can achieve this internally within a manufacturer, or you can achieve this internally within the end users before they use them too much, you can catch things, you can save the company a ton of time, effort, and it's looked upon as a very positive thing. So the better you can achieve getting validated collection process information for field failure data, the better, right? And I just wanted to stress on that because so many people perceive failures as a really bad thing. In reality, it's something that you can now grow on and become that much better. And your failure data analysis, we use the predictive analytic statistics as a benchmark to tell us, well, you need to know, well, how deep do you have to dig? How good is this data collection process? Is there a discrepancy? And if there is, can you explain why there's a discrepancy? Because a good data collection system can be implemented without a major expense. Many people think this can't be done, but in fact, if you have a good system, the expense is minimal to implement something, and a good data collection system with predictive analytics can provide consistent results across many sites and applications, helping save your company a lot of time and money. And I wanted to keep it brief. I wanted to get through that information. I have a lot of questions here, so I'm going to start at the top and start working through these questions because I see some pretty good ones. It seems you place more faith or predictive lambdas using the FMEDA than on field data. Certainly you make some great examples of this. Okay, well, yes and no. What you need to know is the information like we've done previous webinars where we explained how it's important that any predictive lambda be based on field return data that has already been validated. And what you can think of as kind of like a closed loop feedback mechanism where if you have validated field failure data, it must be used in an FMEDA to get that realistic results. Exida has a detailed paper even talking about how we compare predictive analytics to the validated field failure data from the field. And if you go on exida.com, you go to the white papers, you can find all these papers here, or even send me a link or an email. There's my email address in front of you, and I'll find it for you. How about that? And we'll make it even easier. So good question. Do the predictive lambdas with FMEDAs also come from manufacturer data? Well, I laugh, but if I'm speaking with Exida, absolutely not. We do not use manufacturer data. Nothing done by Exida is based on this manufacturer data. Why? Because it's so optimistic. Other certification bodies that do perform FMEDAs, they will include manufacturer warranty data, mainly because they don't have the database that we have. They don't have this predictive analytic kind of thing that we have. Well, I mean, we have 250 billion unit operating hours. We took the due diligence before even knowing what it was going to gain. We did this, well, Dr. Goebel did this because he knew where he was going with this company. And so we did this ahead of time, and it has paid off dramatically. And no other agency took the time to do something like this. And so they have to use manufacturer warranty data, which we all know is very optimistic. And the database must also be field calibrated. And, you know, we do have even other webinars even on that topic specifically. So good question. But no, we do not use manufacturer warranty data. All right, let's see here. And I kind of just answered this question, but how much data was used to validate the FMEDA component database? At this point, we've collected well over 250 billion unit operating hours for all types of systems. And of course, this is from manufacturers, it's from end users, it can be from our SILSTAT users. But it is some of the best, but obviously some of the best data that we feel is from that end user. We will not do a predictive analytics on a product type until we have at least 100 million unit operating hours of each product. So even if we have something categorized, it's because we've already accumulated over 100 million unit operating hours for that type of product. And like I said, you know, this has taken us well over a decade to compile. So this is not something that was done overnight. Good question. All right, next one. Generic SIL3 logic solver data in SCRH. Is this a worst case in class? Yeah. We use predictive analytics. That we use the results to also establish the Exida generic failure rate data. And the concept is if you ask for a set of generic data, then we must assume it's the worst design. Why? Because this is safety, and that's what we're going to have to do. Because we don't know how you operate, and we don't know what type of product that has and what the components inside there. So yeah, we have to do worst case. So we look at the predictive analytics, and we give a conservative range, and then we also check out, well, actually you could even check out silsafedata.com, and you can actually on your own see where your product lies. All right. All right, so how to find or validate failure data from products that are not SIL certified. Exida does a lot of FMEDAs for valve manufacturers to predict the failure rates. Right? Oh, so what they're asking is if there's a product that's not SIL certified, what do we do? Well, yeah, we do a lot of FMEDAs, and a lot of FMEDAs, they don't have to get certified. They want to know what their range is. And so if a certification is not in the picture, one does an FMEDA. And we've done close to 95% of these valves on the market. And if you're very confident, here's another thing though, if you're very confident that a valve or any product has a similar design and strength as another SIL certified, so if yours is not, but you see one that is SIL certified and you think, hey, mine's just like this, and you want to compare your designs to that product, that will help give you a range of where your failure rates lie. Now, I recommend that you may want to put like a 2x safety factor on there because you're not exactly, because maybe you don't know exactly what's involved with that product. And that just to be more on the conservative side, but and there's no harm comparing products. However, we do not recommend you publish anything if you're just doing a comparison. Excuse me. All right, let's see here. All right, I don't want to take too much of everyone's time. Let me do one, maybe two more questions here, and if I don't get to your question, I'll answer it offline. If failure rates from the component database that exida uses and the FMEDA are validated with field data, why do we want operators to collect failure data? That's a good question. All right, the key answer is that if you collect data, you'll be able to identify and sort the differences between product-specific failures and site-specific failures, okay? So that's the biggest thing is you'll be able to specify the different set of failures, and if you have a good process and yet you still find failures higher than they should be, now you know you have a problem. But it's a problem you can fix. Because you have validated data, you now can really see that you have a problem. And when they're identified, they actually reduce their failures. Why? Because now you can solve that, and you can reduce these failures. And it could be in the product selection process. We've seen problems in maintenance procedures. And really, from our experience, we see a lot of issues in proof testing and repair procedures. That's where we've heard many products are even being damaged. All right, and then finally, the last question I have here, specifically, what types of failure data requires for this tool? If you want validated field failure data, you're going to want to record any type of failure, whether it's systematic, whether it's random, whether it's even, hey, we painted this product the wrong color, right? You want to record everything. And the reason for that, the more information you record, the more statistics, the more analysis you can now do on that product. So it's not really what types of failure data that you need for this tool. It's more, it's everything, right? You want to record anything, something does not go to plan, you need to write it down and write all the information down. Write what the model number is, the serial number, write what happened. If you see it more than once or it seems like a bigger issue, do that root cause analysis if you see it all the time and start troubleshooting and finding out. Yeah, it sounds like a little bit more work, but that little bit more work can save companies millions of dollars, and we see it all the time. And just get into that good practice. And like I said, this is nothing, I mean, exida can help you, but this is something that you can do yourself, and that's why we find it so valuable. We love this topic because end users can now gather better field data and start seeing results and can start helping themselves. And with that being said, that's all the questions. I really appreciate everyone's time today. You have all the links there in front of you. I put that there so you don't lose them. The Site Safety Index is a great thing that you can go to learn from site-to-site failures, right? So you can see the differences between site-to-site. We have the safety blogs. You have your still safe data, so you can learn ranges between valves, actuators, and everything like that. That database will grow as well. And yeah, so I thank you so much for your time. I hope you found it useful. If you have more questions, please email me. Take care. Bye-bye for now.